In this video, we're going to be covering straight line graphs, and what we're going to be going through are all the concepts that you will need to know and understand in order to complete all the exercises in this, which is chapter 15. So we're going to start with the Cartesian plane. The Cartesian plane is a grid consisting of 4 quadrants, and that comes about by intersecting two axes, a y-axis, which is the vertical axis, and a x-axis, which is the horizontal axis. We'll get into details of the Cartesian plane in a later video, but for now, all you need to know, and you must have surely done this in previous grades as well, is that we have a set of points in each quadrant. We've got 1, 2, 3, 4 quadrants, and in each quadrant we have points. Points are listed as x, y. So a point consists of an x coordinate and a y coordinate. The x coordinate is listed first and then the y coordinate. So we start on the x-axis and then we plot a point according to what its relevant or corresponding y value is. So if we want to plot the point 3, 5, we'll go to 3 on the x-axis and then we're going to move up to 5 on the y-axis. So we can just do that, and we can label this point A 3, 5. So every point is listed as xy in the Cartesian plane. And from knowing this now, we are going to move on to the straight line graph. Now, the straight line graph, the general equation, and again, you should have already been introduced to this in previous grades. This is the general equation y equals mx plus c of a straight line graph. M represents the gradient of the line, and c represents the y-intercept. So if we have a straight line, for example, this straight line drawn, let's start with C. C is the y-intercept. It's the point on the y-axis. It's the point where the straight line cuts the y-axis. So we'll call this point B, right? And we always list a point as the x-coordinate first and then the y-coordinate. The x-coordinate on the y-axis, this is an important point to make. The y-axis is called the y-axis because there are only y values on that axis. That's what's called the y-axis. In other words, every single point on the y-axis has got an x-coordinate of 0. So, in other words, the equation of the y-axis is in fact x equals 0. Likewise, the x-axis is called the x-axis because there are only x values on it. In other words, all points on the x-axis have got a y-coordinate of 0, and therefore the equation of the x-axis is y equals 0. So when we talk about a y-intercept, we're talking about points that lie on the y-axis. So all points on the y-axis have got an x-coordinate of 0. So the x-coordinate of B is 0, and the straight line cuts the y-axis at minus 5. So B's y-coordinate is minus 5. Right, so C is minus 5 for this straight line. And we always indicate a straight line with arrows. We just put arrows at either end of the straight line to indicate that the line continues indefinitely. So that's the value of C, the y-intercept. Now to find the gradient of a straight line is given by the change in y values over the change in x values. y2 minus y1 over x2 minus x1. x1, y1, and x2, y2 are just any 2 points that lie on the line. We've already got point B, 0 minus 5, that's 1 point. If we look at this point over here, we'll call this point D, just so we don't confuse it. But by calling it C, then confuse it with this over here. We'll call it point D. The coordinates of D, the x-intercept, we're going to list the x-coordinate first, which is 4. And on the x-axis, all y coordinates are 0. So D is the point 4, 0. So the gradient of AB, let's list this as the gradient, not the gradient, sorry, the gradient of BD will be y2 minus y1 over x2 minus x1. So the y coordinate, y2 will be 0, y1 will be minus 5. So it's 0 minus 5 over x2, which is 4, minus x1, which is 0. minus minus 5 is going to be 5, positive 5, 4 minus 0 is 4. So the gradient of AB is 5 over 4. So if we want need to make a correction here, this is not the gradient of AB. This is the gradient of BD. If you want to know what the equation of line BD is, right, so the standard form is y equals mx plus c. The gradient of BD is 5 over 4, so y equals 5 over 4x, and c is minus 5. So this line y equals 5 over 4x minus 5 represents the equation of BD. Okay, so if a straight line is y equals minus 2x plus 3, this is standard form because standard form is y equals mx plus c. So you can clearly see that the coefficient of x is m, the gradient. So the gradient is minus 2, and the constant term is c. So c equals 3. Another one, y equals 3x minus 7. The gradient is the coefficient of x, which is 3, and the y-intercept is minus 7. If we have 2y equals 4x minus 12, this is not standard form because standard form is y equals mx plus c. This is 1y, this is 2y. So what we're going to do is we're going to divide every term by the coefficient of y such that we get just y on its own. 4x divided by 2 is 2x, and minus 12 divided by 2 is minus 6. This is now in standard form, and now we can write down what the gradient is. The gradient is 2, and the y-intercept is minus 6. Let's say we have a line 2x plus 3y equals 6. This is clearly not standard form. The standard form of a straight line. The standard form of a straight line is y equals mx plus c. We need to get the straight line in that form in order to write down the gradient and the y-intercept. So the first thing we're going to do is we're going to have y on its own first. So we're going to move 2x across to the right. So 3y equals minus 2x plus 6. This is still not in standard form because we want 1y. This is 3y. So now we're going to divide both sides by 3 such that we get only y on the left. And then we have minus 2/3 x plus 6 divided by 3 equals 2. This is now in standard form. We can clearly see that the gradient of this line is minus 2/3, and the y-intercept c equals 2. Another example, 7y plus 14x equals minus 21 equals 0. Again, this is not standard form because standard form is y equals mx plus c. So we're going to first isolate the term that contains y. 7y equals 14x will move over to the right, so it becomes minus 14x. And minus 21 also moves to the right and becomes positive 21. Still not in standard form because standard form is y equals mx plus c. So we always have to get a single y, one y. So we divide by 7, each term by 7, such that we'll have y on the left. Minus 14 divided by 7 is minus 2, so y equals minus 2x. 21 divided by 7 is 3. This is now in standard form, the gradient of which is minus 2, and the y-intercept equals 3. So whenever you are required to find the gradient and the y-intercept of a line, you always have to express that line in standard form first, and then you can read off the gradient and the y-intercept. When it comes to sketching straight line graphs, generally two accepted ways of doing so. The first method is what's called the table method. Just to introduce sketching straight line graphs, we will use the table method, but it's very time consuming to draw up a table and then plot all the points. We're going to do a couple of examples, but generally, the best way to sketch a straight line graph is to use what is called the dual intercept method. And that just involves determining the intercept of the axes. A straight line graph has got one y-intercept and one x-intercept. Once you find those intercepts with the axes, plot those 2 points and you put a straight line through them. That's just the best and simplest way to sketch a straight line graph. So before we get to the dual intercept method, we are going to first do the table method. Let's say we want to just sketch the function y equals 2x plus 4. Right? We'll draw up a table of values, and when you draw up a table of values, you can use a ruler. You draw up a neat table. We're going to start with our x values, y equals 2x plus 4, and we are now going to choose dummy values. Now, the general rule of thumb is to have at least 5 values in your table, just so that you can get a nice graph out of it. You really only need 3, but 5 is a nice number to use. So we're going to start with 2 values on either side of, we're going to choose 2 values either side of 0. So -2, -1, 0, 1, 2. Generally speaking, these are the values that we choose. We get to choose the values of x. Whatever values of x we choose, we then substitute it into the function y equals 2x plus 4. We get the corresponding y values, and then we plot the points. So at the end of this, we're going to have points that we're going to plot. So when x is -2, we'll have 2 times -2 is -4. -4 plus 4 is 0. So the y value is 0 when x is -2. The y value depends upon the x value, and that depending on the function that you are working with, you're going to have different y values. When x is -1, 2 times -1 is -2. -2 plus 4 is 2. When x is 0, 2 times 0 is 0. 0 plus 4 is 4. When x is 1, 2 times 1 is 2. 2 plus 4 is 6. When x is 2, 2 times 2 is 4. 4 plus 4 is 8. So we now have the point -2, 0, -1, 2, etc. So we're going to plot the x coordinate first and then the y coordinate. So we start with -2. There's -2 on the x-axis and the y value is 0. So the y value is 0 on the x-axis. So this is our first point, A. When x is -1 over here, y equals 2. So at -1 on the x-axis, we move up to 2. And we call that point B. When x is 0, y is 4. X is 0 over here, origin. And then we go up to 4 on the y-axis. I'm going to call that point C. When x equals 1, y equals 6. Here, this on the x-axis, this is where x equals 1. And then we move up to where y equals 6. I'm going to call that point D. And then the last point we have is x equals 2. Go to the x-axis where x equals 2 and move up to 8 on the y-axis. Now you would have noticed, and you should already know this, that x values to the right of origins. Origin is where the two axes intersect, and that's generally the point O, where x is 0 and y equals 0. X values to the right of origin are positive. They get more and more positive the further away from origin you move to the right. The further you move away from the origin but to the left, the more negative the x values get. So the x values get smaller and smaller as you move to the left of origin. As you move above the x-axis, away from origin, the y values get more and more positive. And as you move down the y-axis, below the x-axis, you move down away from the origin, the y values get more and more negative. So that's how we know when we have our points here. If we take -1, 0, we start at -1 on the x-axis, and this is +2, which means we move up. If y was negative, we would move down. If x is positive, we move to the right. If x is negative, we move to the left. And now that we've got these 5 points here, we just put a straight line through them. We've now sketched the function y equals 2x plus 4. We're not going to sketch this function, but we're going to use the dual intercept method. Okay, the dual intercept method, the function is y equals 2x plus 4. That's the straight line we're going to sketch. The dual intercept method involves us finding the x-intercept and the y-intercept, and then taking those 2 points, the resulting points that we get, plotting them and drawing a straight line through them. So the whole setup, to find the x-intercept, we put y equal to 0. This has already been explained. The x-axis is called the x-axis because all points on the x-axis have got a y-coordinate of 0. So the equation of the x-axis is y equals 0. So this is where that comes from. Then likewise, to find the y-intercept, we put x equal to 0. Again, the y-axis is called the y-axis because every point on the y-axis has got an x-coordinate of 0. In other words, the equation of the y-axis is x equals 0. So that's where this setup comes from. So now we take the equation and we apply these two. So when y equals 0, 0 equals 2x plus 4. We now solve for x. X is minus 2. So we write it down as a point, minus 2, 0. Let's call this point A. And the y-intercept, we put x equal to 0. So y equals 2 times 0 plus 4. Y equals 4. And a point is always written as the x-coordinate first, then the y-coordinate. The x-coordinate here was 0. So 0 is first. And then whatever the y value is listed after that. We call this point B. So now we're going to plot these points, minus 2, 0. So minus 2 is your x-coordinate. There's minus 2. And the y-coordinate is 0, which means we are on y-coordinates are 0 on the x-axis. So this is our point A. The y-coordinate is, sorry, the y-intercept is the point 0, 4. So we start at 0 on x. Always list the x-coordinate first. So at the origin. And then we move up 4 because it's positive y, so it's positive 4. So we move up to 4 on the y-axis. And this is our point B. Now we've got 2 points. Those are the intercept of the axes, and we just put a straight line through those 2 points. As you can see, it's much quicker to use the dual intercept method because we've only got 2 points that we need to worry about. So this is the line 2x plus 4. Okay, we're now going to discuss parallel lines. If two lines are parallel to each other, it is because their gradients are equal, right? Parallel lines are lines that never meet. And you must have come across parallel lines in one form or another, either in Euclidean geometry or as part of the straight line function, which you should have been introduced to already. So if we have the equation y equals 2x plus 4, and another line y equals 2x minus 7, these lines are parallel. Without sketching these two straight line graphs, we know that these lines are parallel because their gradients are equal. The gradient of the first line is 2, and the gradient of the second line is also 2. So because the gradients are equal, these lines are parallel. So if we just call this gradient 1 equals 2, and gradient 2 is also equal to 2. So because gradient 1 equals gradient 2, we'll just call it line 1. If we just call this line 1, and we call that line 2, line 1 is parallel to line 2. And we know this just by looking at the straight line graphs in standard form. Right? Standard form, y equals mx plus c. Always express a straight line in standard form first, and then you can, by looking at the straight line graph, the straight line function in standard form, we can then determine if if two lines are parallel or if they're perpendicular. We're going to move on to perpendicular lines in a bit. We're first going to deal with parallel lines. So these two functions have been sketched. The blue graph is y equals 2x plus 4, and the red graph is y equals 2x minus 7. So now that we've sketched it, we can clearly see that these lines are parallel. They're never going to meet. And the reason they're parallel is because their gradients are equal. So this is the criteria behind parallel lines. We will know if two lines are parallel just by looking at their gradients. If the gradient of one line equals the gradient of the other line, then those two lines will be parallel to each other. That's the criteria behind parallel lines. Moving on to perpendicular lines now. By expressing two straight lines in standard form, we can also tell if those two lines are perpendicular to each other or not. So if we have a straight line y equals 2x plus 4, and a straight line y equals minus a half x minus 7, the gradient of the first line is 2. Gradient of the second line is minus a half. Now, if the first gradient times the second gradient equals -1, then line 1 will be perpendicular to line 2 again. We'll call this line 1 and we'll call that line 2. So this is the criteria for perpendicular lines. We write the straight line function in standard form. Remember, standard form is y equals mx plus c. We then write down the gradient of each of those lines. If the product of the gradients, product means times, if the product of the gradients is -1, then those two lines will be perpendicular to each other. That's the criteria for perpendicular lines. If gradient 1 times gradient 2 does not equal -1, if it's any other value, then those lines are not perpendicular to each other. So for parallel lines, just to recap, for parallel lines, if gradient 1 equals gradient 2, the lines are parallel. And then for perpendicular lines, if gradient 1 times gradient 2 equals -1, then the lines are perpendicular. If the two gradients are not equal, the lines are not parallel. If the product of the gradients of the two lines is not equal to -1, then the lines are not perpendicular to each other. And those are the two criteria. For parallel lines, the two gradients must be equal. For perpendicular lines, the product of the gradients must be -1. I've sketched the two functions again. So y equals 2x plus 4 is the blue line. And the red line is y equals minus a half x minus 7. These lines are perpendicular to each other, so we can mark that they cut at 90 degrees. And they cut at 90 degrees because gradient 1 times gradient 2 is 2 times minus a half, which equals -1. Because of that, because gradient 1 times gradient 2 is -1, the two lines are perpendicular to each other. So line 1 is perpendicular to line 2. Okay, we're going to move on to the gradient, midpoint, and length of a line segment. The gradient of a line segment, you should have already been introduced to. The gradient of a line is given by y2 minus y1 over x2 minus x1, which is commonly written as delta y, or the change in y, over delta x, the change in x. Right? So if we have 2 points, A, 4, 5, and B, 2, 2, then the gradient of AB will be y2 minus y1, so 5 minus 2, over x2 minus x1, 4 minus 2. That'll be 3 over 2. So the gradient of AB is 3 over 2. The midpoint of line segment AB, the midpoint of any line segment, is given by the sum of the x coordinates divided by 2, the sum of the y coordinates divided by 2. And we're talking about the midpoint, right? The keyword is point here. So the point is an x and y coordinate, and it's enclosed in brackets. So the midpoint of AB is x2 plus x1. So it's going to be 4 plus 2 over 2. And then y2 plus y1, 5 plus 2 over 2. That equals 4 plus 2 is 6. So just write it 6 over 2. 7 over 2, which we write as 3. 7 over 2. Just note we are not going to be expressing or writing any answer as a decimal anymore. Answers are always left as improper fractions where applicable. So the midpoint of this line segment, you can just call that M. Let's call it a different letter. Let's call it T. So T is the point 3, 3.5 or 3, 7 over 2. The length of a line segment, commonly abbreviated as D, is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared. This formula for the length of a line segment stems directly from Pythagoras' theorem. We're not going to get into that proof because it's not required. It's not necessary. We're just going to use the formula as it is given. So the length of AB. So instead of writing D subscript AB, we're just going to write the line segment that it comprises, which is AB. AB equals the square root of x2 minus x1, so 2 minus 4 all squared, plus y2 minus y1 all squared, 2 minus 5 all squared. That equals the square root of minus 2 squared plus minus 3 squared. Minus 2 all squared equals 4, minus 3 all squared equals 9. So AB equals the square root of 13. This is how we leave our answer. We do not express any answers anymore as a decimal. Answers are exact. Exact meaning no decimals. So our answer is AB is the square root of 13. And these three concepts, the gradient, midpoint, and length of a line segment, is applicable in the section called coordinate geometry.